Hello, everyone. Let's see, who do we have here? It looks like we have a good amount of people from what I'm seeing, 76 people, 78 people. How about everybody says hi in the chat? Put where you're phoning in from. I want to know who I'm talking to here. I'm in Canada, on the west coast of Canada. My name is Jay Bell. I'm the CTO and co-founder of Charles.org. I have the chat up here on my right-hand side, so if I'm looking over here, I'm looking at you. Don't worry, I'm not looking at something else. I got all my notifications muted for the time being. Okay, Calgary, Canada. I see some Canada, England. Okay, the Commonwealth. I like that. I like that. Lots of down south, my southern neighbors. Who else do we got here? Washington State, right below me. BC, nice. Ashley, where are you from in BC? If you don't mind, you don't have to tell me where you're from, but just interested to see how close we are to one another. Spain, nice. Oh, I love Spain. Been there, I think, once. Beautiful, beautiful. Saskatoon, beautiful. Saskatoon's such an amazing city. Wow, we got a lot. 110 people. Oh man, I gotta step this up. Last year, I don't even think we had 40. Okay. I feel like we're gonna have a question or two by the end of this. So why don't we get started? If you want to keep talking in the chat, all good. If you have any questions, you can put them in the chat, but we would prefer you use the Q&A feature. Jonathan he's my moderator. He will try and remind you to put them in the Q&A, but at the end, I will go through all the questions. We can talk about anything. So if you have any questions whatsoever, I know this is pretty highly technical. I'll try to make it as simple as possible, but it's pretty technical stuff. The couple things I'll mention throughout my talk, I can provide these slides to everybody at the end. Jonathan can give me the list, I can email them out, or he can email them out. There's links throughout. I point to different resources. So if you want to dig into anything, I should have it linked in the chat. But otherwise, just ask a question and we can really get into it. So thanks for coming today. Today, we're going to be talking about AI constituent matching with a dash of deduplication. So, everybody here should probably know what a constituent is if you're here for a Blackbaud talk, right? Constituent matching and data deduplication is such a big thing when dealing with CRMs and large amounts of data. So I want to talk about how we can leverage AI and AI tangentially related systems to AI to help with your constituent matching and your deduplication process. But first, who am I? Well, I should say co-founder. Sorry, Justin, if you're watching this. Co-founder and CTO of Charles.org. We're a fundraising platform for charities, fully integrated with Razor's Edge in case there's any customers here. I'm an Angular Google developer expert, an NX champion, and a huge open source advocate. So I've hosted and been co-hosting on numerous podcasts around open source. I do a lot of open source work. I'm very active in the community. If you want to check out any of my profiles, all the links to them are there below. Again, we'll send this out to everybody if you want it. What is Trellis? Where and why does AI constituent matching matter to us, and why am I here talking about it? Well, we're an all-in-one fundraising tool for charities and nonprofits. We collect a lot of donor data throughout all of our features for all of our customers, and you need to get that into Razor's Edge somehow, right? And because there's so much of it, and you work at a place that has lots of donor data in there already, you don't want to be creating duplicates, and you don't want to be creating all these constituents that already have someone there. How do the different relationships work with the primary and the secondary and the spouses and all of that kind of stuff, right? So that's a big problem that we had here at Trellis when it came to building our RE integration. We have a fully auto-syncing RE integration, but we had to build out a constituent matching system so that we're not messing your data up. So we offer ticketing, auctions, raffles, funded needs, among many other things to help you improve your fundraising. A couple of case studies that I like throwing these out here just to see and just to show the kind of impact that we're having. GBGH, it's a big hospital over in Ontario, which is Eastern Canada. They raised over $655,000 on our platform. Jim Pattison. So if you're from Canada, you know who Jim Pattison is. If you're not from Canada, you might even know who Jim Pattison is. They raised an additional $14,000 in donations by using Trellis for the raffle. If they would have used other products, they wouldn't have gotten that money because the other products don't collect donations. Maybe we forced the industry to change a little bit. Some of our competitors may have started now, but So let's get to the meat and why all 141 of you are here. So AI constituent management with a dash of deduplication. We definitely want that deduplication in there. Otherwise, we're going to be messing up your data. So have you had any of these questions before? What exactly is AI in this context? What's a vector store? Does LLM stand for linguini loving marmoset? It doesn't. Spoiler alert. Is AI going to take my job? Hopefully? Question mark, asterisk. Maybe you don't want it. Maybe you want it to take some of your jobs, because like sifting through data is just no go, right? We do not want to be doing that. That is boring. Let's get AI to do that kind of thing so you can focus on the real problems. And then how can my application solve the two constituent problem? Also, keep a lookout for Easter eggs throughout this whole thing. So what exactly is AI in this context? Well, AI is a pretty broad term, let's be completely honest here. You know, James Cameron kind of put this idea in our heads that AI is, well, the left, right? And in reality, how that's happened in real life kind of looks more like the right so far. Now, obviously we've made some advances since this GIF was created, but this is what people generally think of when we talk about AI. So we're not talking about that kind of AI here, right? We're not talking about killer robots. We're not talking about systems that are taking over the world, asterisk, yet, right? So as of today, AI is more akin to fancy autocomplete in Skynet. They're statistical models. They're trying to guess what the next character is in the response they're giving you, right? So what we have right now is called a large language model. And what these do is, if you ask it a question, like if you say hi, right? It says hello. It starts to look at its statistical model and figure out, well, what should I respond with? Well, it starts to type hello, and then it's either going to be hello there or hello world, right? Those are maybe statistically, those are the two most likely words that come after hello. And that's how it determines, it kind of statistically builds this response, right? A far cry from Skynet. So how does AI know anything, right? Like if it's just a statistical model, how does it know any information? Well, these statistical models have to have a data set to build those statistical links up, right, over time, right? So these models are trained on a certain set of data up into a date. So if anybody remembers when like ChatGPT came out, I think they had trained the original model up to September 1st, 2021 or something like that, right? So it doesn't know any information after that date. It might be able to guess it just by generating more text, but it doesn't know it. I mean, do they know anything? Yeah, I don't know. It's more of a philosophical question. But so how do we provide data to these AIs? Well, usually it's through something like a vector store, by being able to query, look up, provide more information to the AI as it's generating. And a vector store is a really optimal way to do that, that allows us to look up data for similar type data. And we're going to get into what those are. So vector stores, you're thinking like, I thought we were talking about AIs, not some kind of like weird database, right? So right now, many AI applications are being built with this concept called retrieval augmented generation, which is RAG. So this is using a vector store or some other storage mechanism. It could just be a basic database, but vector stores are one of the ways that a lot of AI applications operate, where your prompt comes in, your question comes in, they'll use that to retrieve a bunch of data from its store. Maybe this is up-to-date information that the model doesn't know about, or maybe it's data specific to your organization, like your constituents, right? And then pass that additional context into the prompt, and then the LLM will generate its response with the context you provided it that you queried from the vector store. So I think my slides are actually turned around. No. Wait, what's a vector, right? Vectors can be many different dimensions. If you remember, I don't know what kind of jobs we have in the chat right now, right? But you probably range from DBAs to people that work at charities. Like you might have a high level of technical expertise, or a low level, right? And maybe you're more of a fundraising manager or something like that, right? But a vector is, its basic level is just an arrow, right? It's pointing in some direction. A two-dimensional vector is going to have an X and a Y axes, and it's going to go some direction, right? But a vector can have any number of dimensions. So a three-dimensional vector, a four-dimensional vector, 5, 6, many different dimensions. So TensorFlow, 512 dimensions. OpenAI embeddings, 1,536 dimensions. So you're probably thinking like, how can an arrow exist in that many dimensions? I thought our world was a three-dimensional world, right? Well, you can't really visualize these things, but that doesn't mean that we can't create these concepts of like what different dimensions within like a vector or a matrix of data can exist, right? So how do we find similar data using a vector, right? Well, they're just arrows at the end of the day, right? So if we have these two vectors, one for JBell, all lowercase, and one for JBell with a capital J and a capital B. Well, we as humans know that's the same name, right? A computer doesn't, right? Unless you do some transformations on it and normalize it in some way, which is one of the methods that we use within Trellis to do our constituent matching. But if we turn these into vectors, the arrows are going to be pretty close to one another, but they're not going to be quite the same because of those capitalization differences. Maybe those capitalizations actually matter contextually within your application for some reason. So Lizzie Schaefer, if you know of Lizzie, she works at Blackbaud. She's great. Shout out to Lizzie if you're here. I don't know if you're here. I hope you're here. I don't know. Anyway, I didn't expect her to be here, but I hope she came to my talk. So her vector of her name is going to be quite a bit different than mine. Now, obviously, this isn't an accurate representation of oh, Lizzie's here. I knew it. Yes. Thank you, Lizzie. Of course you're here. Okay. Well, you made it into my slides yet again, 2 years in a row. So Lizzie's vector is going to be very different than mine. We share like 2 letters, right, across our names. So very, very different vectors. A computer is going to see those as incredibly different. And there are lots of ways that you can calculate the differences between vectors. So how is this helpful for constituent data? You're wondering, like, Jay, you're talking about all these vectors and dimensions and arrows and capitalization and all this kind of stuff. Well, users aren't good at entering information. If you've ever had to clean data, clean information, they're really, really bad at it, right? And there's a lot of systems out there that are trying to clean up data. So maybe they misspell something. We get people misspelling gmail.com all the time on Trellis when entering emails into our checkup form, for example, right? They may misspell their name, or maybe their autocomplete saved something that was misspelled, right? So or maybe they use like an abbreviation versus not, like seventh, right? With the letters or just a number, right? We as humans, again, our brains are great at recognizing this and knowing that those are the same thing, but computers don't, right? So Dwight says, it's this close. They're actually the same contextually, but they're not the same functionally from what characters there are there, right? So how do we use this idea of, well, they are the same to actually tell the computer that they're the same? Where's the AI? Where's the AI? So AI is smartest when steered. These are all links, so when you get this, you can go and look up all of these. AI provides best practices on prompt engineering. Now, when this slide deck was created, I don't believe OpenAI had released the reasoning models yet. So there's a slightly different idea behind reasoning models versus non-reasoning models. But the general idea is the same. You want to prompt engineer, steer, tell it what to do, right? It's pretty good at guessing what you want, but the better you are at telling it, the better it will be at giving you an answer. So include details in the query relevant to the answers. Looking up something in a vector store. If you know you're going to be asking it to do a certain task and provide a context related to that task. Tell the model to adopt a persona. You are an expert data analyst. That'll kind of put it in the metaphorical mindset that it is there to analyze data. Delineate information in the query. Use XML, JSON, Markdown to separate the sections. Specify steps to complete complete the task. Provide examples. Examples are king when it comes to prompt engineering. And provide specifics in the length of the output. Give it, I only want 2 sentences. I only want a sentence. I want 1 paragraph, stuff like that. So what does prompt engineering actually look like? Oh man, we only have 14 minutes left and you guys are gonna have questions. Okay, so prompt engineering, you're an expert data analysis and matching user entered information to information in a CRM to reduce duplicates. You should match the input data to potential duplicates using the following matching algorithm. It's very simple, natural language, tell it what you want. So details and persona, you are this. This is your job. Labeling the sections, here is the matching algorithm. Here is the data to find a match for. Here are potential duplicates, right? Like really telling it like this section is this and this section is this. And then specify the steps required. So that's for constituent matching, that's going to be our matching algorithm. How do you at your charity or your organization do constituent matching? What do you look for to determine if 2 constituents are the same? Everyone does it differently. That's why it was so hard for us to build our original system that has this whole matching algorithm in it, fuzzy matching algorithm in it. So describe the matching algorithm in natural language. And then using structured output, we can get something that can be parsed by a system so that we can then use the result. You're probably thinking like, do I sound like this? Like there's this over here is vector stores and there's matching algorithms and there's markdown and all of this stuff, right? So the process, determine your matching algorithm so you know what data to vectorize. This is what data you're going to turn into vectors so you can look it up against vector store. If you're not matched on a first name, don't vectorize the first name. Vectorize all existing constituent data on your primary matching criteria. That's the stuff that you care about as an organization to determine for the matches. Load the constituent vectors into a vector store. Some options there. There's so many out there now, it's crazy. Vectorize the primary matching criteria of the input. This is the potential duplicate that you were looking for. Query the vector store for similar vectors, potentially similar constituents. Grab the constituent information for that vector, so all of that constituent information, and then feed the matching algorithm, what you care about matching on, the input data, the potential duplicate, and the vector data, all the possible duplicates into the LLM. Define the matching criteria. So using AI, right, you can give it how you, like, just imagine you were talking to a new data analyst or a new DBA or someone saying like, Lizzie, we match on last name. And then if last name matches, we also double check that the address line number 1 is the same. So pull constituents from Razor. We're going to just walk through like an actual literal example now. So pull constituents from Razor's Edge. These are some potential duplicates, right? So you got Sarah Connor, John Connor, and Miles Dyson. Vectorize each one, put it into a vector store. This allows us to query it. Query for similar vectors. So our input is, oh, there's another Sarah Connor here. Okay, well, let's vectorize this new Sarah Connor input and then query our vector store for this. See if there's any potential duplicates, right? And then finally, this is kind of all wrapped up together. We're saying, you are this, your job is this, here's the matching algorithm, here's the input data, the second Sarah Connor, and here are the possible duplicates, Sarah Connor, the original Sarah Connor, John Connor, and Miles Dyson. And then, so breaking down, this is just really what we're breaking down here. So we have the system prompt, this is the persona, the job, description, stuff like that, the matching algorithm, the user, this is that you as the user are telling the AI, does this person match any of these people? And you can see that Sarah Connor and John Connor got returned as potentially similar vectors. And drum roll, what's it going to give us? So the input, Sarah Connor. The result is this matching ID, and that matching ID actually matches to Sarah Connor, the original Sarah Connor. So you can see that the AI is seeing that if you can find the difference there, the only difference between those two is one says APT4 for apartment and one spells out apartment 4, right? So again, humans, great at figuring that out. A computer, just without any transformation, wouldn't necessarily be able to know. But what we did was we were able to find similar vectors, i.e. the Connors, right? And then check against another Connor that came in, and it actually gave us back the right matching ID and said, hey, your Sarah Connor matches this Sarah Connor in the vector store. And I ripped through it because I got a 14-minute warning a little while ago, and I wanted us to make sure that we had enough time for questions. Here's a list of links about me, about the tech we talked about. One thing I'll note is LangChain's great, and it's been improving a lot over the years, but there are so many other libraries out there for interacting with this stuff. Some of them are a lot more user-friendly. They all have strengths and they all have weaknesses. This uses LangChain. I can use a lot of stuff. So, but you can use a lot of things to build these systems. And then of course, there's lots of AIs beyond OpenAI out there. So let's get to questions, because I know I ripped through that. Someone said I need an hour. I probably do need an hour. Maybe I should submit an hour talk next year. We'll see. But yeah. Jonathan, if you want to join me on stage, we can go through some Q&A. I see. Okay. See, I'll go bottom top because those are the most recent. Oh no, Holly asked about slides. Yep, we're good to go. Downloadable. Yep. Okay. So in terms of accuracy, how do these AI matching algorithms compare to fuzzy matching algorithms? So this is from Carlos. I mean, as with everything, it depends. It depends, right? Like, how good is the fuzzy matching algorithm we're talking about, right? Because there's going to be a bunch of them out there. How well are you prompting the API or the AI? What instructions are you giving it? What model are you using it, right? Like for these relatively simple cases, like these John Connor, Sarah Connor cases, let's go back up from here. It's going to be really good, but you're thinking, oh, this is a pretty trivial case. It's just APT instead of apartment, right? Like you could write your own little code algorithm that would normalize that. And that's actually part of what we've done at Trellis. But once you get into these more intricate matching criterias and it's more different, maybe it's 309 W, APT, LA, CA, USA, and then the other one's just completely spelled out, right? Now, that's a relatively trivial one because those are all standardized abbreviations. What if they start misspelling things, right? So it depends. If you can do it strictly with code and a fuzzy algorithm, you probably should. But the great thing about the advent of all these AIs is that they can solve some problems that are sometimes way more complicated when it comes to writing the code. Okay, Amanda, can it be trained to find non-constituent spouses? We often have spouses nested as non-constituent relationship records. But if the spouse gives or signs up for an event on their own, a duplicate, unconnected new constituent record is created. I mean, yeah, so you can train it to do whatever you want, right? Again, you can use AI, you cannot use AI. Our system at Trellis does what you're asking for there. We have spousal support in our constituent matching system. But again, the sky's the limit with these AIs and LLMs. If you want to prompt it in a way where it matches your case, you can absolutely do that. They're really smart, especially with these reasoning models that didn't exist when I originally put this deck together, right? They're really good at thinking through problems. And if you prompt them in the right way to say, this is how we handle spousal records, it's pretty good at figuring that out, right? What tools did you use? ChatGPT versus VS Code, like where you were parsing this sort of thing I'm new. Yeah, no worries. All good, Lydia. So I'm using the APIs, like the AIs that back ChatGPT. So using the same ones that ChatGPT use, but I'm using them from a programmatic context. So all of the OpenAI APIs and stuff like that, and built my own scripts for it. There's lots of utilities out there, like for example, LangChain here, but another one like Vercel. I'll type it in the chat. The Vercel AI SDK. This is the one that I've kind of pretty much just switched to using now. It's super user-friendly, super easy to use from a coding point of view, that is. And I found it to work a lot better. It didn't exist when I wrote the put this doc together originally.
And Jay, I have a question.
Yep.
Are these the AI tools you're using? These are ones that are not free. I assume these are subscription based.
Yeah, so with OpenAI, you pay it's like a usage-based model. So you pay per how much you use, and tokens. A token is anywhere from like 1 to 4 characters. You pay like $1.50 per million tokens or something like that. Like it depends. Each model is priced differently too, because some take more computing power. But yeah, there is the option to run models locally though, and then those would be completely free. It's a little bit more overhead, and you got to like figure out what you're doing. If anybody's curious, you can use Ollama to run models locally. I just put it in the chat, as well as which would then you could run like say Llama 3 from Meta or DeepSeek, for example. You can run all those models locally and then connect the tools you're using that I talked about to your local model instead of to OpenAI, and then you're not paying anything.
Thanks.
Yeah, no worries. Tori, so as a use case, you would have a secure AI connection hooked into your database and then ask these types of questions to identify duplicates. Not quite. So what you would have, there's a middle step there that I talked about with the vector stores, where you would need to take the data from your database, or in this case from the CRM, like find all the constituents in your CRM, vectorize each of those into a vector database, and then your system. And I mean, like things have evolved and they're evolving so much every day that some of these AI tools can probably just connect directly into your vector store, for example, right? But then what you would do is when you go to look for Sarah Connor, see if there's a duplicate, you would then query your vector store with the new Sarah Connor information and find a duplicate, right? Now, there's different ranges of amount of effort on your part, right? Like there's going to be tools that just like from a website you can click and connect them together and all that kind of stuff, right? And there's going to be tools, and then or you could just build your own system for it, right? So there's a whole range of things. But yeah, really what you're doing is you're feeding your vectorized data into an AI to get the response. I hope that that question, obviously, we can go pretty deep on, so I don't really have the time to go through all of it, but hopefully that gives you a general idea of what I'm talking about here. Good.
And Jay, we're just about at the end. I'm going to launch the survey right now. If you all could just take a couple minutes to fill that out, we'd love to get your feedback about what you loved about Jay's presentation, maybe what you'd like to see next year's Dev Days, but we'd just love to get your feedback. Really appreciate that. And I think we still got a little bit of time for a couple more questions, but I just wanted to put that survey in the chat. And also, before everyone goes, I really want to thank you for participating this week, and thank you for coming to the session. And thank you to Jay. This was an absolutely fantastic session, Jay. Thank you so much for being a partner of ours and for doing this as well. And Jay is from Trellis, as he mentioned, which is a Blackbaud partner. Awesome. So sorry, Jay, go ahead and get a couple more questions.
2 more questions here. I'm going to try and rip through them. Sarah, I hope I answered your question with the answer to Tori. There's going to be tools that do it for you. You could build your own system for it. It's really choose your own adventure at this point with all the tools that are coming out like daily. Perfect. I did. Okay. And then Yosef has a great question here about data privacy, right? Like this big deal, right? Nowadays. Would you be uploading your donor information to vector stores? Yes and no. Also, does that matter? Yes and no. Does it matter? Yes and no is, are you hosting the vector store yourself? If so, you're not really giving it to a third party. It's your database. And then in terms of if you're using an external one, yes and no. The vectorized data can't necessarily be reversed all the time. I'd have to look at exactly how different it is, but really all you're doing is putting a vector of something that means something to you in this vector store, and then you reference that in your database. So again, it all kind of depends, but you can host a lot of these vector stores yourself. And then of course the data privacy problem is on you. Is your vector store secure, right? You're not necessarily uploading it through a third party. The Pinecone, I think you can host yourself, but the other 2 are hosted services. There are tons of vector stores you can host yourself though. Okay, 10 seconds. I think I covered everybody's questions. I hope you enjoyed my talk, and thanks for coming.
Thanks so much, Jay, and thanks so much, everybody, for attending. And everyone, have a great rest of your day and enjoy the rest of the BB Dev Days conference. And have a great rest of the afternoon.
Bye, everyone.